Throughout the 1960s and 1970s, one aircraft dominated the world of air combat, the incomparable McDonnell F-4 Phantom II. A perfect marriage of engine and systems in a sturdy airframe, the Phantom was the right aircraft for virtually any task it was asked to perform. Built in enormous numbers for the US forces, the Phantom was also a great export success. Wherever it operated, the Phantom outshone the opposition, both its contemporaries on the flight line and the enemy aircraft it encountered in the air. This was underlined by a long and distinguished combat record in both air-to-air and air-to-ground roles. Some aircraft are just right from the outset, and the Phantom was one of those. It is a testament to the soundness of the design that some 20 years after more modern aircraft arrived to replace it, sizable numbers of Phantoms are still operating in front-line roles. Long range was at the heart of the requirements that gave birth to the Phantom, so it was necessarily big to accommodate enough fuel. The engines were spaced far apart to provide high internal volume for fuel carriage. The wings were necessarily big to provide sufficient lift, especially for getting the aircraft safely back aboard the carrier. It also had to fit into a carrier's hangar deck, so it could not be too large. The outer wings folded upwards to reduce its footprint on the deck, but it remained one of the largest carrier-borne fighters ever, dwarfing some of its deckmates, such as the F-8 Crusader and A-4 Skyhawk. The overall size of the Phantom came to be an advantage, especially for the US Air Force that used it more in the fighter-bomber role. In performance terms, the Phantom was without equal in its early career. A spectacular series of world records underlined this, claiming top figures in absolute altitude, sustained altitude, absolute speed, and low-level speed. There were also numerous closed-circuit and point-to-point speed records, and a series of time-to-height figures that were only beaten by the F-15 Eagle. Clearly, the Phantom was a winner. However, it was not the most maneuverable of aircraft, although it could hold its own in a dogfight, especially after leading-edge slats were fitted in later aircraft. It nevertheless needed to be treated with respect when being flown hard in a fight, as it had some notable handling deficiencies. The Phantom was designed first and foremost to be a missile fighter, but later it greatly expanded its repertoire to encompass the use of many classes of weapons. For its initial role of missileer, it was designed with 4 troughs in the lower fuselage for the semi-recessed carriage of Sparrow missiles. Initially known as the AAM-N6, before being redesignated as AIM-7 in 1962, the Sparrow used semi-active radar homing. The launch aircraft illuminated the target with a continuous wave, and the Sparrow homed in on the reflected signals. For shorter range combat, the Phantom was also provided with launch rails either side of the inner wing pylons for the carriage of sidewinders. Initially known as the AAM-N7 before becoming the AIM-9, the Sidewinder used a heat-seeking guidance method. US Air Force Phantom settled on the Sidewinder as the main short-range missile, but did briefly use the Hughes AIM-4 Falcon before reverting to the more reliable Sidewinder. Other air-to-air missiles were used by export customers. For instance, the RAF used the Sky Flash, based on the Sparrow and externally similar, but with a new seeker. Israel fitted its Phantoms with Shafria and Python 3 missiles, while Germany's upgraded aircraft adopted the AIM-120 AMRAAM. For the F-4E at least, another air-to-air option was the M61 Vulcan cannon. The weapon used linkless ammunition fed from a large drum mounted between the radar and the cockpit. The proximity of the gun to the radar needed careful attention to the reduction of vibration to avoid damaging the sensitive radar equipment. For those Phantoms that did not have an internal gun, the SUU-16 and SUU-23 gun pods were available. These self-contained units accommodated a 20mm Vulcan cannon with up to 1,200 rounds. Phantoms occasionally flew with 3 gun pods, but the standard load was a single pod on the center line. The Phantom had 5 external hardpoints for the carriage of weapons, fuel tanks or pods, 1 on the center line and 2 under each wing. As the aircraft's career progressed, the number of air-to-ground weapons that could be employed mushroomed, a process accelerated by the war in Vietnam. The use of triple and multiple ejector racks allowed the carriage of large numbers of bombs. Free-fall bomb options included the entire Mark 80 series, plus older generation weapons such as the M117 and M118. Export operators also used their own weapons. In Vietnam, the M117 and Mk-82 were the most common bombs to be employed. The Mk-82 was often fitted with a daisy cutter fuse extender, which ensured that the bomb burst above ground for maximum blast effect against personnel and soft-skinned vehicles. For low-level attacks, the Snake Eye retard tail was fitted. As can be seen here, the Snake Eye employed 4 pop-out wings that decelerated the bomb, giving the Phantom time to escape the blast. Later, the Snake Eye fin kit gave way to the Air Inflatable Retard, or AIR tail, which deployed a balut to slow the bomb down. Area denial weapons were used widely in Vietnam. These could take the form of cluster bombs or various dispenser systems that delivered the sub-munitions as the aircraft flew overhead the target area. The sub-munitions were mainly for anti-personnel duties, including the so-called jungle bomb that had a single tail that span it round so it could more easily penetrate the foliage of the jungle canopy. Firebombs, better known as napalm, were also widely used. They contained a thickened fuel-based gel which scattered and ignited on impact. Other Vietnam specials were illumination flares for night attacks and bombs that dispensed propaganda leaflets. Rockets also formed part of the Phantom's armory. Mostly the 2.75-inch Mighty Mouse carried in 7 or 19 round pods and with a variety of warhead options. At the other end of the weapons spectrum, American Phantoms were wired to carry nuclear bombs. The tactical B-28 could only be carried on the centerline pylon, but the B-43, B-57 and B-61 could be carried from any pylon apart from the outer starboard. A typical loadout would have been 2 on the inner wing hardpoints, with fuel tanks and self-defense weapons also carried. The Phantom was instrumental in the widespread fielding of precision-guided munitions, beginning with the simple radio-guided bullpup seen here. Laser-guided weapons such as the GBU-10 and GBU-12 Paveway 2 came to be regular Phantom weapons. Electro-optically guided bombs and missiles were also used, notably the GBU-8 and 9 Hobo weapon. This had a TV seeker in the nose. Once locked onto its target, the bomb's contrast tracker guided it to a direct hit. The range of EO bombs that the Phantom could carry later expanded to include the AGM-62 Walleye, and this, the GBU-15 glide bomb. Both used a data link that allowed the backseater to control the bomb in flight, steering it to a very accurate strike. The AGM-130 powered version of the GBU-15 was also tested on the F-4E. The TV-guided AGM-65 Maverick missile was another weapon routinely employed by the Phantom for precision attacks. Many other weapons were employed by the Phantom, including Israeli-developed Gabriel and Popeye precision missiles and the Mitsubishi ASM-1 anti-ship weapon. For the specialist defense suppression role, U.S. Air Force Wild Weasel Phantoms used the AGM-45 Shrike, AGM-78 Standard, and AGM-88 Hahn, all of which homed in on the emissions of hostile radars. In its day, the Phantom was the most sophisticated fighter in the air. Although its radar was pedestrian by today's standards, in the early 1960s it was considered a phenomenon. The APQ-50 fitted to the first handful of F-4s gave way to the APQ-72 with a 32-inch antenna. It was optimized for air-to-air and was highly regarded. The APQ-100 of the F-4C was similar but had expanded air-to-ground modes, while the APQ-109 in the F-4D introduced solid-state technology and was therefore lighter. The APQ-120 of the F-4E was completely solid-state and had an elliptical antenna measuring 27.5 by 24.5 inches. The size reduction was necessary to fit in the confines of the F-4E's smaller radome. Augmenting the radar in the F-4B was an AAA-4 infrared search and track system, or IRST, mounted under the nose. This was cued by the radar and provided passive tracking of aerial targets. Although the IRST fairing was fitted to Air Force F-4Cs, the equipment itself was not installed, and in the F-4D, the fairing was used to house radar warning equipment. As the missile threat increased during the Vietnam War, so the provision of effective warning and countermeasures increased. Warning antennas sprouted from the tail cone and fin tip. The Navy's F-4J dispensed with the undernose fairing altogether and was fitted with the APR-32 radar warning system. The countermeasures systems of the F-4E underwent several changes during the variant's lifetime, but late-model aircraft settled on ALR-46 warning receivers located in the tail cone and in wingtip fairings. Jamming was provided by podded systems, the most common being the ALQ-87, 101, 119, 131, and 184. This is the ALQ-131 that was widely used in Europe. Late F-4Es also introduced the ASX-1 TISIO, standing for Target Identification Sensor Electro-Optical. This was mounted in a pod on the port wing leading edge and comprised a closed-circuit TV camera that could be used for the long-range visual acquisition and tracking of targets. Export operators often fitted their own systems to the Phantom. For instance, RAF Phantoms were given Marconi ARI 18228 radar warning receivers in a fin-top box fairing and could carry an EMI multi-sensor reconnaissance pod on the center line. Japan's Phantoms also had some local systems installed. Some F4EJs were later modified as RF4EJs to carry podded reconnaissance systems. With its low-profile canopy and cluttered instrument panel, the Phantom offered the pilot a poor view of the outside world compared to today's fighters. The poor forward visibility was particularly noticeable during carrier approaches. The two crew sat on Martin Baker ejection seats, which were thoroughly tested on a sled track. As engineers crammed more and more instruments into fighters, so the cockpit became increasingly complex. And as pilots fumbled around in the dark to find ever more switches and read ever more instruments, so the danger factor increased. The Phantom, the F4E in particular, was the aircraft that began to reverse the trend, and it was an important stepping stone to the clear and easy-to-use cockpits of today. The F4E introduced a measure of head-up flying, and some switches were moved to the throttles and stick, although the Phantom was not a HOTAS, head-up aircraft as we know today. Above the instrument panel in the front cockpit was an optical sight. In the bombing roll, it showed bomb aiming cues generated by the weapon's release computer. This was introduced by the F4D, and was one of the first such systems fitted in a fighter. Against aerial targets, the sight displayed automatically generated cues from the lead computing system. This took data from the radar and the aircraft's air data system. Below the sight was a circular display for the radar, together with controls. Some of the radar controls were located on the throttle. To the right of the radar was a smaller circular screen for the 360-degree radar homing and warning system. This showed hostile radars as spikes, varying in brightness according to their strengths. Below the radar screen was the flight director system, comprising an altitude director indicator that combined the functions of several previous instruments into one easy-to-read unit, and a horizontal situation indicator that was the primary navigation instrument. To the right of the flight director system was the primary altimeter, below which was a vertical velocity indicator and a backup altitude display. To the right of that group were the fuel gauge and primary engine instruments. To the left of the flight director system was the airspeed and Mach number indicator and an angle of attack indicator. Further to the left was a radar altimeter dial. The panel below was the armament control panel. Small panels were mounted low down to the left with various secondary instruments. In the center were further dials for oil and hydraulic pressures and remaining cannon rounds. And to the right was the main circuit breaker panel. On the left side console were mounted the twin throttles and a number of secondary switches, mainly for aircraft systems such as flaps and slats, drag chute, fuel control, and engines. The starboard console area mainly consisted of switches for the communications and navigation system, as well as aircraft lighting and cockpit temperature. The rear cockpit of the F-4E was fitted with full flight controls, and much of the top of the main panel was given over to flight instruments. The main display in the back was the radar screen, often fitted with a hood so that the weapons system officer could view the screen without distortion from extraneous light. The left side console accommodated the main radar switches and sensor select unit, with navigation and other switches behind. On the right side console, there were further sensor controls, including a stick for slewing radar and other cursors. There was a keypad for data entry, and at the back, a nuclear stores consent switch. In the early stages of its development, the Phantom was to have been powered by the Wright J65, but McDonnell adopted the new General Electric J79 before detailed design work began, and this engine became the bedrock of the Phantom's considerable success. The single-spool J79 turbojet introduced variable incident stator vanes, allowing it to compress air to a much greater degree than earlier engines with fixed vanes. The engines were installed in the rear fuselage and were tilted slightly to give a small downward thrust component. The Phantom also featured the first fully variable supersonic intake system ever fitted to a fighter. It underwent several design changes before settling on the final version. All Phantoms were built with variants of the J79, apart from those for the United Kingdom, which specified the Rolls-Royce Spey turbofan instead. The Spey required more air, and the intakes were correspondingly larger. The Spey offered more thrust at low altitude, although the larger intakes increased drag. At high altitude, the J79 had the edge. Fuel was accommodated in the wings and in 6 bladder tanks in the fuselage. The system could be filled through a single-point pressure nozzle. A boom receptacle was mounted on the spine for mid-air refueling. The landing gear was built tough to absorb the punishment of carrier landings. It was designed to cope with a sink rate of 22 feet per second at an aircraft weight of 33,000 pounds. The Phantom landed with little or no flare, and the undercarriage took quite a pounding during every landing, whether it were afloat or ashore. The F-4B had an extending nose wheel that increased the aircraft's incidence for carrier launches. It was attached to the catapult shuttle by means of a heavy strop that hooked on to attachments under the leading edges. The arrestor hook deployed down from beneath the tail and was fitted to both naval and land-based versions. The extreme tail accommodated a brake chute. The outer panels of the wings folded up to reduce the area that the aircraft took up on the carrier's deck. All flight control surfaces were hydraulically powered, comprising a single-piece rudder and all moving stabilators that could move up to 20 degrees up or down. Roll control was provided by a combination of ailerons and spoilers. The ailerons were situated on the outer section of the horizontal wing section. They only moved down and were augmented by spoilers. The spoiler section was mounted on top of the wing immediately forward of the aileron. Thus, to roll to the right, the port aileron was lowered and the starboard spoiler was raised. Simple flaps were mounted on the inboard wing trailing edge. The entire leading edge of the wing was designed to droop at low speeds in 3 sections. To further increase lift at low speeds, the leading and trailing edge flaps were blown with high-pressure air bled from the engine compressors. Partway through the F4E production run, the drooping leading edges were replaced by 2 sections of powerful slats that greatly increased combat maneuverability. Against an unslatted aircraft, the slatted F4E could complete a 180-degree turn in 14 seconds, leaving its rival several hundred yards behind and outside the turn radius. Phantoms entered service with the US Navy in 1960, delivered to the training units VF-101 Grim Reapers and VF-121 Pacemakers. The first frontline unit to get the type was VF-74 Bedevilers, which transitioned to the new fighter in July 1961. Carrier qualifications were undertaken in October, and from August 1962 to March 1963, the Bedevilers took their F-4Bs aboard USS Forrestal for the Phantom's first full carrier deployment. By the time of the Gulf of Tonkin incident that marked the US Navy's entry to combat in Vietnam, 13 fleet squadrons were flying the Phantom, and the type went on to serve with 27 active duty fighter squadrons, plus another 4 reservist units. Deployment with the US Air Force got underway in 1963, the first aircraft going to the 44 53rd Combat Crew Training Wing at MacDill Air Force Base in Florida. The first operational unit, the 12th Tactical Fighter Wing, was formed at the same base. By 1965, Air Force F-4Cs were stationed in Thailand for Vietnam War service. As large numbers of F-4Cs were delivered, then followed by Ds and Es, the Phantom rapidly became the US Air Force's primary tactical aircraft, equipping wings at home, in the Far East, and in Europe. It adopted the air defense mission, flew on conventional attack duties, and, especially in Europe, became the main tactical nuclear delivery platform. RF-4s, like these aircraft, also became the US Air Force's main tactical reconnaissance vehicle. The third US service to get the Phantom was the Marine Corps, which flew F-4Bs on close support duties and also flew the RF-4B reconnaissance variant seen here. As well as operations from shore bases, Marine RF-4Bs also detached to US Navy carriers. Phantoms from all 3 services were deeply embroiled in the war in Southeast Asia, and the Phantom became the most important aircraft of the Vietnam conflict. Navy Phantoms flew from carriers sailing in the Gulf of Tonkin, while Marine Phantoms operated from South Vietnamese airfields. Air Force aircraft operated mainly from Thailand, but a few were also stationed in South Vietnam. Primary missions were close support of US ground forces, interdiction and air superiority. In the latter, the F-4 fought a bitter battle with the more agile MiG-17s and MiG-21s of the Vietnamese People's Air Force, eventually triumphing as the US changed its tactics. Phantoms were responsible for over 145 aerial victories during the war, at a kill-loss ratio of 3.73 to 1. In the interdiction role, the Phantom was used for both low and high-level attacks against many types of targets. Many of the missions were simple bomb track sorties, delivering weapons from medium or high altitude. Others involved Phantoms getting down and dirty at low level, running the gauntlet of ground defenses. For the most part, Phantoms employed dumb weapons such as bombs, cluster munitions, napalm and rockets. But as the war progressed, so the use of guided weapons increased. The Phantom became the main laser bomber and used paveway weapons in a series of well-publicized attacks on vital North Vietnamese bridges. Marine Corps and Air Force RF-4s shouldered much of the tactical reconnaissance burden in Vietnam, losing many aircraft to ground fire in the process of what was one of the most dangerous missions of the war. Phantoms reigned supreme in the US forces throughout the 1970s, but by the end of the decade, a new generation of fighters was beginning to supplant the old warhorse. F-15s and F-16s replaced F-4s, while in the mid-1980s, the FA-18 Hornet began to replace the F-4 on US Navy carrier decks. Nevertheless, large numbers of Phantoms continued to serve in the fighter-bomber role with Reserve and Air National Guard units, while the specialist F-4G Wild Weasel and RF-4C reconnaissance versions served into the mid-1990s, including participation in the 1991 Gulf War. As they were retired, many airframes found a new role as QF-4 target drones. Able to be flown in either manned or unmanned configurations, QF-4s were and still are an important part of the United States weapons development and training program. Of course, the Phantom also saw much service overseas. Israel took delivery of around 220 F-4Es and RF-4Es, the first arriving in September 1969. The Phantom was used in many combat actions. Another Middle East operator was Iran, which received 225 F-4Ds, Es and RF-4Es. They were used in the 1980s war with Iraq, and a fair number remain operational. Following the historic Camp David Accord of 1979, Egypt was offered a batch of 35 F-4Es, which it accepted to equip 2 squadrons of the 222 Tactical Fighter Brigade at Cairo West. In Europe, West Germany bought 175 F-4Fs to equip fighter and fighter bomber wings, plus 42 RF-4Es for reconnaissance. Several F-4Es were sent to the US to equip a German training unit there. Fighter Phantoms are still in service in Germany, having been upgraded under the ICE program. However, they're in the process of being replaced by the Eurofighter. Greece also has Phantoms in service, having upgraded some of its F-4Es to a standard similar to the German aircraft. Turkey operates a large fleet of F-4Es and RF-4Es. Some were delivered as new, and others were surplus US and German aircraft. The type continues in use, some F-4Es having been upgraded by IAI in Israel to the 2020 configuration. The UK bought 2 Phantom versions, the carrier-capable Phantom FG Mark I, which served aboard HMS Ark Royal until the vessel was withdrawn, and the Phantoms given to the RAF for air defense duties. Meanwhile, the RAF's own batch of Phantom FGR Mark IIs was initially assigned to battlefield interdiction and reconnaissance duties. When they were replaced by Jaguars in this role, they also became interceptors. Towards the end of the Phantom's RAF career, a batch of former US Navy F-4Js was born to supplement the fleet. Two nations operate the Phantom in the Far East. The Republic of Korea has a wing of F-4Ds, a wing of F-4Es, and a single squadron of RF-4Cs. Some of the F-4Es are equipped with the PAVE-TAC laser designation system. Japan is the biggest operator in the region and the only country to build the Phantom under license. Mitsubishi produced 140 F-4EJs for the Japan Air Self-Defense Force, and they entered service in the air defense role. In the late 1980s and early 1990s, they were upgraded to F-4EJ Kai standard with APG-66 radar and other improvements. As the F-16 Eagle took over the fighter role, some F-4s were re-rolled for anti-ship and attack missions. Some were switched to reconnaissance duties as RF-4EJs using podded systems. Japan also bought 14 RF-4Es direct from the US to fly with the 501st Tactical Reconnaissance Group at Hayakuri. Other countries to operate the Phantom are Spain, which had F-4Cs and RF-4Cs, and Australia, which briefly flew the F-4E while it waited for deliveries of its F-111s. Both home and overseas, the Phantom was an enormous success. When Mitsubishi delivered the last F-4EJ to the JASDF in 1985, it was the last new-build Phantom. The production total stood at 5,195, a figure unmatched by any Western jet fighter, apart from the Sabre. The Phantom performed many roles, from point defense interceptor to nuclear bomber. One mission for which it became very well known, at least in the US Air Force, was the lethal suppression of enemy air defenses, or SEAD. Known as Wild Weasel, this mission was developed during the Vietnam War as a means of countering surface-to-air missiles. Pioneering work was performed by the F-100 Super Sabre and F-105 Thunder Chief, but it was the Phantom that made the lethal SEAD role its own. Nowhere would the Wild Weasel role have been more important than on the Central European front in the final years of the Cold War. In this scenario, the Wild Weasel Phantoms would have been used to punch holes through the first layers of the Warsaw Pact's air defenses. Creating gaps in the defensive line allowed strike packages to pass through without the threat of SAMs, so they could continue to their targets deeper inside enemy territory. Wild Weasel Phantoms operated in pairs to provide mutual support. Sometimes the pair consisted of two of the specialized F-4G defense suppression version. In Europe, however, the F-4G operated as one half of a Hunter-Killer team, partnered by an F-4E. To cater for any aerial opposition it encountered, the F-4G carried 3 AIM-7 Sparrow medium-range air-to-air missiles in the fuselage bays, and 4 AIM-9 Sidewinders on the shoulder launch rails of the wing pylons. The port-forward Sparrow Bay was usually used for the carriage of an ECM jamming pod, in this case the ALQ-131. A drop tank was usually carried on the center line, and for all but short-range missions, further tanks were carried on the outer wing pylons. The inner wing pylons carried the all-important anti-radar missiles. The first weapon to be employed was the AGM-45 Shrike. This was a 400-pound weapon with a Texas Instruments seeker that homed in on radar emissions. For longer-range attacks, the AGM-78 Standard ARM was developed, this mating the seeker from the Shrike to a much larger missile body, giving a range of around 17 miles when launched at high speed. Towards the end of the Phantom's defense suppression career, the AGM-88 high-speed anti-radiation missile, or HARM, was introduced. A normal load was 2 missiles on the inner wing pylons. Backing up the F-4G Hunter was the F-4E Killer. This carried a similar weapon loadout with Sparrows, Sidewinders, tanks and ECM pod, but did not have the necessary equipment to employ the anti-radar missiles. Instead, it carried bombs or other guided missiles. In a central front scenario, a wild weasel pair launched ahead of the attack package and approached the battle zone at low level to avoid detection by enemy radars. A racetrack orbit was established a few miles back from the front line. The first task was to compile an electronic order of battle, or EOB. The F-4G Hunter popped up from low level into the regard of the enemy radars. The APR-38 radar homing and warning system got to work. APR-38 consisted of 52 different antennas distributed around the airframe, although many were grouped in the fin-top fairing, and the under-nose fairing with its distinctive four-leaf clover array on either side. The system was operated by an electronic warfare officer nicknamed the Bear in the back seat, who had a number of specialized displays. The system identified radar signals by comparing them against an onboard threat library and displayed their positions on a PPI screen. Anti-aircraft gun radars were annotated as A, while SAM radars had a figure to denote the type of missile system. A figure 6, for example, identified the missile system as an SA-6. The system also prioritized the radars, with the most threatening having a triangle superimposed. With the EOB compiled, the F-4G returned to low level. The pop-up maneuver may have been repeated a number of times to monitor enemy radar activity. At the appointed time, the F-4G went into the attack. With key radars designated by the system, the Phantom launched its anti-radar missiles. If the radar operators were smart enough, they would shut down the radar, but if they didn't, then the missile homed in on the signal and destroyed it. For the Weasel crews, the act of shutting down the radar by their presence was considered job done in any case, as the radar would not be a threat to the attack package. If the radar had been destroyed, the F-4E Killer would follow up with a conventional attack against the radar installation and its associated missile batteries, either using bombs or AGM-65 Maverick guided missiles. With a section of the enemy's air defenses disabled, the attack package flowed through. Further Weasels accompanied the package in the SEAD escort role, firing anti-radar missiles ahead of the formation to protect them against SAMs en route and in the target area. The Phantoms would also cover the egress route to make sure the attackers recovered safely to friendly airspace. was to emerge as the Phantom we know today began life in 1952, when the US Navy issued a requirement for a supersonic fighter. That competition was won by the single-engine Ford Crusader, but the twin-engine design submitted by the McDonnell Aircraft Company of St. Louis, Missouri showed considerable promise, and work continued on refining it. In November 1954, the US Navy requested 2 prototypes of a derivative optimized for multi-role operations under the designation AH-1. It was to have had 11 hardpoints for the carriage of stores and a 2-seat cockpit. Just a month later, the Navy changed its mind and decided it wanted a long-range missile-armed interceptor instead. McDonnell ditched the provisions for attack weapons and reworked the design to have fuselage troughs for Sparrow air-to-air missiles and an APQ-50 air-to-air radar. The designation was changed to F-4H-1 in June 1955. Numerous wind tunnel tests were undertaken, and an instrumented scale model of the new design was tested by being launched by rocket. Construction of the prototypes began in late 1955, and Robert Little flew the first from St. Louis on the 27th of May 1958. Soon after, the aircraft went to Edwards Air Force Base, where it convincingly beat the rival Crusader III in evaluations. During the design process, the F-4H had undergone a number of significant changes. The wing was originally a conventional shape with straight leading edge and folding outer panels. In the final configuration, the outer panels were bent upwards by 12 degrees and extended in chord to form a dogtooth. This formed a powerful vortex at high angles of attack to improve lateral control. Another unusual feature was the downward-turned tailplane. Tunnel tests showed that the F-4H required a large amount of fin area to maintain directional stability. However, due to the constraints of having to fit in a carrier's hangar, the fin could not be made any taller. The designers were left with no alternative but to slope the tailplanes up or down. The latter option was chosen, with 23¼ degrees of anhedral being applied. The result was anything but beautiful, leading to the aircraft being sneeringly referred to as the bent-wing bird or the double ugly. Beauty is only skin deep, however, and the F-4H was, by some margin, the most advanced fighter of its day. It was called Phantom II. McDonnell's original Phantom was this aircraft, the F-H, a first-generation straight-winged carrier jet of the late 1940s. A small batch of F-4H-1Fs was built, seeing service primarily for test purposes. The 19th aircraft introduced 2 main changes that changed the shape of the Phantom forever. Firstly, the canopy line was raised to provide a better view for the crew. And secondly, the radome was enlarged to accommodate the larger dish of the APQ-72 radar. The first major production version was initially designated F-4H-1, but soon after its entry to service, it was redesignated as the F-4B, the earlier aircraft becoming F-4As. The B was a carrier-borne version that was similar in most respects to the late production F-4A. 649 were built, and the first entered service in 1961. US Air Force interest in the Phantom was dramatically aroused when early Navy F-4Bs were evaluated against the Air Force's F-106 fighter in Operation High Speed. The Phantom exhibited an all-round superiority in the air and also dramatically reduced maintenance requirements. Immediately, the Air Force borrowed a pair of F-4Bs for further evaluation, the type receiving the designation F-110A. Orders followed swiftly, eventually totaling 583. The first flew in May 1963, by which time the version had been redesignated F-4C. The Air Force Phantom was similar to its naval counterpart, but had an APQ-100 radar with enhanced ground mapping for attack missions and a full set of flying controls in the back seat in line with Air Force policy to have 2 pilots. The Air Force went on to order 825 F-4Bs. While this was generally similar to the C, it was the first model designed specifically to Air Force requirements and had numerous differences, chiefly concerning equipment. The main new features were the APQ-109 solid-state radar and an undernose fairing housing radar warning receivers instead of an infrared detection system. US Air Force requirements also drove the development of a tactical reconnaissance version, the RF-4C. This was based on the F-4C fighter but had a revised nose section. The tip had a small radome for a mapping and terrain avoidance radar, but the lower part of the forward fuselage was given over to reconnaissance sensors. A bulged fairing housed forward and downward-looking cameras, while side-looking cameras peered through windows in the side of the nose. The cameras were mounted on drop-down doors for rapid access to the film magazines. Behind the cameras were a side-looking airborne radar and an infrared sensor, both recording images onto film. RF-4Cs retained a bombing capability, including the ability to carry nuclear weapons. The Marines bought a similar aircraft designated RF-4B. And the Recce Phantom was cleared for export sales as the RF-4E. Albeit with several key systems removed. RF-4s underwent various upgrades and carried various podded systems. A related variant was the F-4ES Shablul, 3 of which were developed for Israel with a massive oblique camera crammed into the nose. Development for the US Navy continued with the F-4J, which introduced the J79-10 engine and numerous aerodynamic changes to improve approach and launch characteristics. In the early 1970s, over 200 F-4Bs were improved to F-4N standard, and many F-4Js were later upgraded to F-4S standard with slatted wings and smokeless engines. The most important variant in the Phantom's evolution was, however, an Air Force-led program. Experience in Vietnam revealed the lack of a gun to be the Phantom's biggest drawback. McDonnell devised a new front end, based on that of the RF-4, in which a 20mm Vulcan cannon could be mounted below the aircraft's nose. The result was the F-4E, which became the definitive Phantom. As well as the gun, the E introduced many other improvements, including -17 engines, and was further developed as production progressed. The most significant change was the adoption of leading-edge slats to dramatically improve combat maneuverability. Nearly 1,400 F-4Es were built. 116 F-4Es were modified to the F-4G Wild Weasel variant. This entailed fitting the APR-38 radar warning system with a new fin tip fairing housing antennas and a new antenna fairing replacing the gun under the nose. The E was also the basis for 2 important export models. In Japan, the F-4EJ was built under license by Mitsubishi, with engine production entrusted to IHI. Japanese Phantoms were optimized for air defense and were later upgraded to F-4EJ Kai standard with APG-66 radar. West Germany bought 175 F4Fs, which were essentially lightened and simplified F4Es. These too were later upgraded under the ICE program that added APG-65 radar and AMRAAM missile capability. Phantoms destined for the United Kingdom were based on the US Navy's aircraft and consequently lacked the undernose gun. The F4K, or Phantom FG Mark I, was a carrier-borne version, whereas the F4M, or FGR Mark II, was a multi-role fighter bomber for the Royal Air Force. In order to keep the British content to a maximum, they were powered by the Rolls-Royce Spey turbofan, entailing a considerable redesign of the intakes and engine bays. Not surprisingly, there were numerous minor versions and a number of upgrade proposals that covered re-engineering and the fitment of new systems and weapons. Shown here is IAI's Kernas 2000 demonstrator, which had Pratt & Whitney PW1120 engines.
次号は SR71。 冷戦時代に活動した第一世代のステルス技術を取り入れたマッハ3の高速偵察機です。極秘のベールに包まれていたこの SR71 を徹底解剖します。次号もぜひお買い求めください。